Hi, this is Teacher Vinch, and now, at this moment, we are going to discuss concept number 3, which is all about the properties of minerals. Minerals occur in a fascinating palette of colors, shapes, and lusters. They vary in hardness and may even have distinctive taste or scent. We will now look at these properties, which are very important or very useful when we identify minerals. So I want you all to listen carefully and write down notes as we discuss this lesson. There are around 8 properties of minerals identified in this module, and there are a lot of activities for you to enjoy, so buckle up and prepare yourself to listen. The first property of a mineral identified in this module is called the crystal form. Crystal form is the external expression of a mineral's internal orderly arrangement of atoms. Generally, when a mineral forms without space restrictions, it will eventually develop into an individual crystal with well-formed crystal faces. As shown here in the picture, the first picture, this is an example of a pyrite. It is an iron and sulfur mineral with a cubic crystals in it. And as shown here in the second figure, this is an example of a distinctive hexagonal crystals of the mineral quartz. This is formed when space and time permit. However, most of the time crystal growth is severely constrained. It is stunted because of the competition for the jammed crystals, none of which exhibits crystal form. This is what happens to the mineral in the granite. Thus, most inorganic solid objects are composed of crystals, but they are not clearly visible to the unaided eye. The second property is identified as luster. Luster is the appearance or quality of light reflected from the surface of the mineral. Minerals that have appearance of metals, regardless of color, are said to have metallic luster, like the pyrite crystal. Minerals with a non-metallic luster are described by various adjectives. These include vitreous or glassy, like the quartz, crystals, pearly, silky, resinous, and earthy or dull. Some minerals appear somewhat metallic in luster and are said to be submetallic. The third property is called color. Although color is an obvious feature of mineral, it is often unreliable in diagnostic property. Slight impurities in a common mineral, like quartz for example, gives it a variety of colors, including pink, purple, or amethyst, milky white, and even black. And the fourth property is called streak. Streak is the color of a mineral in its powdered form, which is much more reliable indication of color. Streak is obtained by rubbing a mineral across a piece of hard unglazed porcelain termed as a streak plate. Whereas the color of a mineral may vary from sample to sample, the streak usually does not, and is therefore the more consistent property of a mineral. Streak can also help distinguish minerals with metallic lusters from those having non-metallic lusters. Metallic minerals generally have dense dark streak, whereas minerals with non-metallic lusters do not. The fifth property is called hardness. One of the most useful diagnostic properties is hardness, a measure of the resistance of a mineral to abrasion or scratching. This property is determined by rubbing the mineral to be identified against another mineral of known hardness. Another mineral will be scratched using this mineral. The geologists use the standard hardness scale called the Mohs scale. It consists of 10 minerals arranged in order from 10 being the hardest and 1 being the softest. Any mineral of unknown hardness can be rubbed against these 10 minerals to determine its hardness. For example, the fingernail has a hardness of 2.5, and the copper of penny has a hardness of 3.5, and a piece of glass has a hardness of 5.5. The mineral gypsum, which has the hardness of 2, can easily be scratched using the fingernails. Quartz, the second hardest, will be common minerals at 7. To further understand the first 5 properties of minerals, we have here a simulation activity. Please press the first link provided in this description box. Pause this video and proceed in answering the activity. The directions will be given. And once you've finished, please continue this video as we will be discussing the rest of the properties of minerals. Good luck! Yay! It seems like you've finished the activity. How was your experience? Fun, isn't it? Well, we have more as we go through this discussion, so buckle up and prepare yourself. The sixth known property of a mineral is called cleavage. Cleavage is the tendency of a mineral to cleave, or break along planes of weak bondings. Not all minerals have definite planes or weak bondings, but those who possess cleavage can be easily identified by the distinctive smooth surfaces that were produced when minerals are broken. The simplest type of cleavage is exhibited by minerals called micas, the one used for cosmetics. Micas have weak bonds in one direction from the cleave to form thin flat sheets. Please do not confuse with cleavage in crystal form. When a mineral exhibits cleavage, it will break into pieces and have the same geometry as the other. But by contrast, the crystals do not have cleavage. If broken, they are fractured into pieces that do not resemble each other or the original crystal itself. The seventh identified property of a mineral is called the fracture. Fracture is a property of a mineral breaking in more or less random patterns, with no such smooth, planar surfaces. Since nearly all minerals have orderly atomic structure, individual mineral grains have external axes of length, width, or depth, related to the consistent arrangement of the atoms. Minerals that do not exhibit cleavage when broken, such as quartz, are said to be fractured. Even fracturing this variety, minerals that break into smooth curved surfaces, like those seen in broken glass, have a conchoidal fracture. Others breaks into spoilers or fibers, or like asbestos, but most minerals fracture irregularly. The last but not the least property of mineral is referred to as the specific gravity. Specific gravity compares the weight of a mineral to the weight of an equal volume of water. For example, if a cubic centimeter of water, its specific gravity is 3. With a little practice, we can estimate the specific gravity of minerals by hefting them in your hand. For instance, a mineral feels heavy as a common rock you've handled. So, its specific gravity would probably be somewhere between 2. Some metallic minerals have specific gravity noticeably greater than the common rock-forming minerals. Galena, which are ore or flead, has a specific gravity of roughly 7.5. The specific gravity of a pure 24-karat gold is known to be hefty 20. In summary, a number of special physical and chemical properties are useful in identifying particular minerals. This includes taste, the smell, the elasticity, malleability, the feels, the magnetism, double refraction, and the chemical reaction to hydraulic acid. Remember that in every one of these properties depends on the composition of the mineral and its structure, or how your atoms are arranged.